Hoist the black flag high, let the cables hum. Code and cannon ready, futures beating like a drum. Charts are drawn in circuits, treasure maps and AI. We're sailing for the edge where bold ideas never die.
Hey, everybody. Welcome to another episode of Pirates Only, a podcast where we talk to early stage founders to dive deep into what they're building, the industries that they're building in, and then also get some tips and tricks for other founders that might be listening as well. Today, I have a very special guest, Brian Taylor, founder and CEO of Aeterna, fellow Colorado company. I always love talking to people in Colorado. We might dive into a little bit on why we think Colorado is the perfect place for more companies to start. We could bring some of that talent here. But before we go down any rabbit holes, I always like to start with a very clear, what are you building? And we find that it's best to put it in the most layman's simplest terms possible, especially for some of the VCs listening that maybe aren't as smart, certainly as you are. So what is it that you are building? And then we can dive into maybe why you decided to go on this journey.
Yeah, absolutely. First off, thanks a lot for having me. Really happy to be here. Big fan of the podcast. We are building reusable satellites to enable fleet operations in space, which has never existed before, and really is the next level to unlock scale in the space industry after launch is no longer a bottleneck.
And as we will certainly get into, I feel like launch is becoming less and less of a bottleneck. And it's been such a cool thing to see so many companies now venturing off into space.
Yeah.
Before we go into the industry itself and some of those things, could you talk a little bit about why you chose to build this? Why now? And then maybe what you were doing before to help inspire you.
Yeah, absolutely. So I'll talk a little bit about my background first, which kind of led into why I start this company now. So I went to college for mechanical engineering. I was this structures mechanical engineer in the aerospace and aviation industry. Before this company, it was about 15 years. About halfway through that career, I ended up at SpaceX in Seattle on the Starlink program. And that really changed my view from kind of working at prime contractors and what I would call boring companies to SpaceX and really getting this strong boot camp understanding of how you can operate differently within the space industry. I actually wasn't a space nerd, growing up and, in high school and things like that. I wanted to work on other things, hardware that I could touch. Satellites in space, other than rockets, were very much this thing that you work on, you put, blood, sweat, and tears into it, and then you send it off and you don't see it again. And you just get, data back from it. And that always bugged me. Once I worked at SpaceX and kind of understood how much ground testing goes into satellites and SpaceX's like kind of special method of moving very quickly at long-term, very low cost, that changed my view of space and what the space industry should be, what it can be, where it is right now, developed opinions about all those types of things. So I started at SpaceX in structures testing on the Starlink satellites. I did all the structural testing for the first stack of 60. A lot of really interesting anecdotes about how we came up with the stacking mechanisms and how that was going to work and how the stage 2 was going to work. Like all of that was only possible because SpaceX owned the satellites and the rocket. If we had gone to another rocket supplier or launch services provider and said, this is what we want to do, they would just laugh us out of the room, right? So Starlink is not possible without owning the satellite and the rocket. And then after that, I did Starlink Aviation, so putting Wi-Fi on planes. I've gotten to experience that on a United flight recently, kind of in the wild, and it is.
And I hope it happens more. I still think it's a unicorn. I think 1 in 50 flights has it.
Yeah.
So I'm hoping that they continue to add more, and I'm sure they will.
It will. They had to start on the small regional planes because of where they got certification, and so that's why. So if you're kind of flying small flights, you usually feel really lucky getting it versus big long haul flights. So it'll come to everybody pretty soon here. So that was really great. And then after that, I went to Amazon's Project Kuiper, and then most recently I was at Loft Orbital. So a lot of that experience was around increasing the rate of building satellites. SpaceX has one method of doing it. which is when you have very high quantities, you have a lot of leverage with the supply chain, and you can do that. Kind of similar with Kuiper. Loft Orbital has a different way of going about that, which is horizontal kind of integration where they buy satellite buses from other people and then integrate those and run them very well on orbit. Those are all different kind of business models to solve a very similar problem, which is we can't build satellites as fast as we want to. And so, you know, I started looking at where the launch industry is, where it's going. We all know that the prices are going down. How far down they'll go, we're not really sure, but they'll probably get cheaper than where they are right now. And supply will go up with things like New Glenn and Stoke and Relativity. And we're really excited for all of those other launch providers. And so I started looking at what requirements on a satellite can be loosened up in order to kind of answer some of these issues that I was having as pain points across these satellite manufacturers. And what I realized is we don't need to optimize mass quite as much. Still can't, send up a steel brick, but you can be a little bit less optimized on mass. And when you do that, you can add a heat shield to a satellite. And when you add a heat shield to a satellite, you get reentry. And when you get reentry, you can do a little bit more, and then you get reusability. And that was the key aha moment for me, where this attritable disposable satellite architecture that exists in the space industry, to me does not compute for the scale that we were trying to go to, right? Falcon 9 launches every 2 days, which was absolutely unheard of, before reusability. And it's because of reusability. So we think that is oh yeah, it's lower cost, but it's actually much higher cadence, much higher reliability, much higher schedule reliability. Today, you can go get investor dollars saying, I'm going to launch on a SpaceX rocket in 2 years, and they believe you. Before Falcon 9, you could not do that. And so that has opened up this kind of giant industry for satellites and more scale, but to me, not quite enough, because now we're limited on how fast we can build satellites. So that to me was the aha moment of kind of nobody else is doing this and somebody needs to do it. And started the company about 1.5 years ago, and we've kind of grown from there. So we can kind of dig in further, but that's the genesis story of Lex Aeterna.
That's great background. I can't believe you said 1.5 years. Is that what you said?
Yeah, that's where we're at. Yep.
That's awesome. And how big is the team?
Yeah, we're at 17 people right now.
Nice.
We've got a 6,000 square foot facility that's behind me. We can build 2 satellites and refurbish a third in this facility, and
that's so cool.
Looking at expansion plans for sure.
I love that. And how much capital have you raised so far?
Yeah, so far we've raised about 15 million across 2 rounds. Most recently, we closed our seed round in February of this year.
That's awesome.
And so, yeah, really excited about kind of what that enables. We're fully funded through our first launch, which is Q1 of next year on a Falcon 9 rocket rideshare, and that'll be a full reentry mission. So we'll be orbital for a couple of months, and then we'll come back through atmospheric reentry, and we'll land in Australia with our friends at Southern Launch.
That's so cool. It's got to be such an amazing feeling to put something into space, but then even more of a good feeling to get it back, because you're exactly right. A lot of the space companies that I've talked to, Matt at Astroforge, which I believe that you know as well. I mean, he would talk about this all the time, where how many things they just send into space and they never see them again. And even then, the data that they have on board, if something breaks or fries out, whatever, it's lost. You're kind of done. And we'll definitely dive more into kind of what you said on the cadence wise, because people I think of the cost savings that happen, but it's the cadence and the speed at which you can learn and iterate that made SpaceX what it is. But I want to pause really quick, because I want to go kind of back a little bit on the SpaceX side. What years were you there with SpaceX?
Yeah, I was there 2018 to 2022.
Yeah. So I feel like that's kind of in this prime. Obviously, SpaceX has been around for longer, but certainly in those late 2000s and then going into early 2020s, that's when people, I think, started to see some of those massive leaps into some of these cost changes. When you were there and working on it, I know you were kind of on the Starlink team, but I feel like, was the vibe internally, did you feel like you were essentially creating what you've created today? When you look at SpaceX, I talked to so many space founders, they point to SpaceX as being the only reason why they can exist. Did you kind of feel that like in SpaceX that you were creating not just obviously game changing technology with Starlink and what you were doing, but the fact that you would essentially create an entirely new industry with founders like yourself that couldn't exist before?
Yeah, absolutely. I mean, I think I would actually point to the transporter and the rideshare program that SpaceX does in general that opens up, single slots from CubeSat to Cake Topper, satellite positions to folks without buying a dedicated launch or getting, kind of the rare rideshare on another main launch. That is what enabled founders like me to get capital and trust that that capital could be used for a launch on a certain schedule. Absolutely, that has spawned so many satellite companies on the application side, the infrastructure side, things like that. My favorite view of any transporter launch is of the stack with all the different types of satellites. So that was a really big key enabler. I think, one of the things that really struck me when we were building Starlink was going from these like big giant step changes in order of magnitude. So first off, we built 60 satellites from zero to launch in 9 months for the very first launch. And that had never
Yeah,
been
unheard
done.
of. Yeah.
Like, couple of zeros had never been done. And that was huge, right? And that's not enough to sustain a communications constellation, right? So then this next step change of launching many satellites every launch, depending on, every week, depending on whatever the cadence is. Um, that scope and consequence and what that did for the entire world of giving internet communications to Native American tribes that were near us in the Seattle and Pacific Northwest, to Australia and, like very, very remote islands, as well as people that were traveling and camping and doing all this. Like the scope and consequence of what we were building was so large. And I never had worked on something that big. And I remember having this thought of like, man, I'm screwed for any job I'm ever going to have after this that has less scope and less
How could you
consequence,
beat
right?
that? Yeah.
Yeah. And so, that was really important to me when I started this company, and I talked to the people that we've hired so far about that it's very important that what we're doing is a mission worth fighting for in terms of how large it is and what consequence it can have across the entire globe. And I think that is the thing that needs to get us up out of bed in the morning and get us super excited to come, during the easy days as well as during the hard days. So,
Yeah,
yeah.
absolutely. Could you paint a little bit of a picture of what maybe that looks like in the next 5 to 10 years as you scale up your company the same way that as SpaceX scaled, it started and kind of bred all these new companies getting started now? What do you envision the world looking like when you achieve your mission over the next 5 to 10 years and then beyond? Like paint a picture of what those unlocks could be.
Yeah. So, we're definitely addressing parts of the existing market in the satellite industry, but really the way that we see it there are these mission architectures that are not even contemplated right now. And
Because
we
of
see
the reentry or the lack of that ability.
and not actually the reentry, it's actually the lead time. So the time it takes to go from mission conception or decision to launch and on orbit, right now, locally for the next year or so is limited by launch, but overall over the next 5-10 years is not limited by launch, but it is limited by satellite manufacturing and the supply chain that feeds into that. And as we scale up, that gets even worse when you need a brand new component for every single component on the satellite. And so when we try and scale that up, that gets pretty difficult. So there's existing missions that we've done in space, and then there are wholly new missions that you don't even conceptualize because it's not even possible. So, I'll give you an example of that. So right now, decision, conception to launch is realistically about 2 years. That's what we're going to do in terms of building a new satellite. There's a couple of people that have done it about 11 months, and it was this absolute sprint, and then they didn't do another one 11 months after that. So generally, like kind of new concept is probably about 2 years best case. So therefore, if you need to make a decision that is based on data that is less than 2 years old, or you want to bring a technology into orbit that is less than 2 years old, you can't do it. And it's not really a thing that you think about. Now, if that lead time was, 6 weeks, 8 weeks, 12 weeks, something like that, that's a massive difference in what you would think about taking to space. And you can think about that based on kind of the latest technology for compute, for Earth observation, for defense ISR applications. If you have the ability to get something into space in 6 weeks, and there's a conflict, you would actually like in that, but you don't think it's going to last 2 years. And so you're not even going to contemplate putting something up when it takes 2 years to get to space. So that's an example of something that we think is going to be normal, commonplace, missions that is not today.
I love that. That's a good example because you're right. There's probably so many things that people in rooms today, if they can only launch one satellite and it takes 2 years for it to be there, the problems that they have today, you almost have to be a fortune teller. You have to predict what problems you're going to be solving in 2 years, which is in this world is very hard to do. But you're exactly right. If it's a matter of weeks, especially you mentioned conflicts, or any particular needs that a country or a company is having right now, it's going to open up a massive amount of applications. So that's awesome. That's great. Are
Yeah.
there other
And it
companies? I mean, do you?
also,
Yeah.
like, really quick, it puts this big lag on iteration. So we talked
Mhm.
about kind of how SpaceX is one of their superpowers is very fast iteration. When you have that 2 year life cycle on kind of just getting to orbit, let alone how long you're going to be in orbit, you have a massive lag in the innovation that you can do based on the number of iterations. So when that lead time gets a lot slower, or a lot faster, excuse me, you can do a lot more iteration loops. And that means the progress that you can make on technology development, on fixing problems, just compresses drastically.
Here's another dumb question for someone like me. How long are typical missions for satellites in space? Because you're today, if it takes 2 years to send something out there, are these missions that people are paying to send satellites in? Are they weeks, days, years? Like, what is an average mission like for a satellite these days?
So there's a lot to dig into there. Actually, just a great question. So generally in low Earth orbit, missions are kind of 5 to 7 years, and there's a couple of things that factor into that. Generally, the only thing that you can do to get more value out of that mission is to make it last longer. There isn't really more value you can do by making it shorter. And so that comes into refueling, on-orbit servicing, things like that, where like, man, if we could get another 2 years out of this vehicle, we would make a little bit more money. But it's not the same value you're going to get out of the first 2 years of that vehicle.
Totally.
And the other thing is when you design that vehicle for 5 to 7 years, you have to make sure all the components and the payload match that lifetime as a minimum. And so you get a lowest common denominator of what determines the failure of the satellite, and then you make sure everything else matches that. And sometimes that takes a lot of engineering effort and work to make one component, match that lifetime that others, it's very easy for them to hit that. And if you think about that on your car, if everything had to last 200,000 miles, including the brakes and the tires and everything, certain things would get really expensive. Certain things would be like totally fine. But you replace them kind of based on what the technology is that is used for that. And, certain things can get replaced without replacing the entire vehicle, right? And so when you go to reusable architecture, like that becomes possible. And that where we didn't actually have a knob to turn on shorter duration missions, we can now do that with reusable satellites and with a fleet architecture that says, I actually want to design my mission to be 1 year. I'm going to have costs that are, equivalent to that 1 year in orbit versus 5 years in orbit. And I'm going to design my payload upgrade, schedule according to that. So yeah, that's a couple ways that we change the way you think about how long do satellites last. Another one there is if you think about the duration of the mission, if it's very long, usually you can take a longer lead time to get ready for that. If we get into those situations where you want a 6 week lead time, chances are you're not going to want a 6 week lead time to launch and a 5 year mission. probably whatever you're doing in space is going to be done in 6 months or a year or something like that. So on either side of launch, you're either kind of long on both sides, lead up and duration, or you want to be really short and condensed, and you get a very high value out of that shorter duration.
Yeah, I love that. So it's almost like you're solving kind of two problems that existing satellites have today, where A, you have to plan for missions that are 2 years out, which drastically changes what type of missions you would do. But then also because of the cost to send them to space and because they are essentially going to be remaining in space for a long duration of time, those are also the missions. You have to think of what missions are 2 years away where we have to have and maintain a satellite for 5+ years in space. But there's probably so many missions that are timing critical where we need this in space within 6 weeks, but then also we need it in space for 6 weeks. And to your point, it only needs to last a year. And I didn't even think about the component side of that, where so much cost probably goes into making these satellites have to withstand, obviously, the incredible elements and lack thereof in space that changes the equation entirely. So
Yeah.
that's really cool. Do you have
Yeah.
and you mentioned like conflict stuff? Are there any other exciting or fun missions that maybe come to mind that people could get excited about or wrap their heads around?
Yeah, so the other one is this like dynamic upgrade cycle for your
Mm,
payload.
mm.
So say you want your constellation, your one satellite or your constellation of satellites to have the latest compute capability for whatever reason. Instead of kind of doing a design for replacement where 25% of your satellites have the latest, 25% have, 1 year or 2 years old, and kind of you can see how that drifts off. If you say the whole constellation, my value proposition is we're going to have no compute that is older than 1 year or something like that, or you want to match the consumer electronics upgrade cycle instead of having that match the lifetime of your satellite. Now you can design a mission around the payload's timeline to refresh as opposed to how long a satellite will reasonably last in low Earth orbit. Obviously, when you get to MEO and GEO, it looks a little bit different, but you can design it based on the payload instead of based on the solar array or the clock cycles or the other things that usually fail first on satellites or the fuel.
Another kind of a random space question is because I don't get to talk to very smart space people as often. What is the difference technically between lower Earth, middle, and then high Earth as far as like the qualifications that you then have to build for? Obviously, gravity, the speed of the objects that are moving at those different orbits. What are some of the things that maybe the audience would be interested in to know, like how different each of those different orbits are? 'Cause I think a lot of people think it's going to space, but each of those orbits have very different ways that you kind of have to build for and think about.
Yeah, totally. So one that's like quite different is the radiation environment, and that varies across the the realm. But you have to design electronics that are called rad hard or radiation hardened versus kind of not. That's always a statistical game. It's never a guaranteed game like some things are in structures, which is where I come from. The other one is really about thermal and power management. So in low Earth orbit, you do one orbit about every 90 minutes, and depending on kind of where you're at and you're between eclipse and power, and right, so it's this 90-minute cycle that's going to be on power versus no power. When you're in deep space, like our friends at Astroforge, you've got one side of the satellite that's going to see sun all the time and one side that's going to see sun never, right? And that's a very different thermal environment that you have to design for. And so you just cannot take the same satellite for low Earth orbit and fly that in GEO or deep space or cislunar or things like that. It's not huge differences. Same architecture generally works, but you just have to plan accordingly to match the concept of operations with the design of the satellite. So yeah, those are kind of a few. There's a couple other differences as well.
One of the things you mentioned earlier to kind of go deeper into what you're building, you mentioned how SpaceX and essentially in order to create Starlink had to like vertically integrate the rocket and shedding stuff into space being a piece to make Starlink even exist. Are you kind of taking those same pieces of vertical integration on the creating your own hardware and software side to make all these things work? And maybe touch a little bit on, is that a unique thing that you guys are doing as far as trying to control the whole operation within the satellites from software and hardware?
Yeah. So when Starlink started, SpaceX was 15 years old or something like that, had launched,
That's crazy. Yeah.
Many rockets, they had their own amazing ERP system. They had all of the support functions of a corporation. They just had this massive amount of infrastructure and corporate knowledge that really, like, that was why it was possible to do 60 satellites in 9 months, right? But we did not just start from scratch as a startup. We did start from scratch as a startup and do not have kind of massive amounts of capital or massive amounts of infrastructure that already exists and things like that. That means that we have to approach vertical integration a little bit differently, and it's absolutely kind of a phased approach. And so, for our initial satellite, the Delphi, the architecture itself is fully owned by us. It's a customized architecture that it looks very different from a normal satellite because it has an integrated heat shield, and we use that as the structure of the bus. And there's certain components that we have to design because they don't exist in the market at all. However, batteries, reaction wheels, torque rods, other people are making those very well. And so we get those from vendors and don't vertically integrate on those. And so we vertically integrate on what we have to. And then as we increase our launch cadence, we will know exactly what we have to vertically integrate on. So it is not a blanket rule. It's vertical integration is king, and we're going to do that on everything. And we're going to take, much longer time between 0 and our first launch. But it's a calculated risk based on, or a calculated decision based on every subsystem and kind of what the existing market is. What changes do we need? Does what the market currently offer, is that sufficient or is it not? And so that's really how we look at it. For sure, we're going to increase that vertical integration as we grow, but it has to be done in a measured way.
I think a lot of folks listening are probably building in hardware in one shape or form. So this won't come as a surprise to them. But whenever I do talk to founders that are pure software, I think they're very surprised at how much software you either have to build yourself to help manage the hardware or to manage all these operations. Could you talk a little bit about that on the software that you're creating? And then another topic that we hear quite a bit now, even in hardware companies, is how much AI is benefiting you from the ability to excel and move much faster. Could you touch on maybe those two things on creating the software side, but then how AI has maybe accelerated you and the team on that too?
Yeah, absolutely. So we build software to run our satellite. It's kind of obvious. And so, we do not consider ourselves a hardware or a software company. We're a spacecraft company, and that spacecraft is capable of re-entry. And you have to do a lot of things to be able to do that. That doesn't define exactly what our company is, right? So we have software and we have hardware, and we need to be very, very good at both of those things, and they have to work together very well. And so we have flight software, which is a separate discipline from ground software, which is a separate discipline from test software, which is a separate discipline from infrastructure. Each of those are software engineers and groups of engineers that have very specialized expertise on exactly what they're building. Very similar to on the mechanical side. Even within mechanical engineering, that covers fluids, thermal structures. You've even got stress analysts that don't touch loads, and you've got loads analysts that don't touch stress, which always I thought was weird. And then you got design engineers that kind of
Yep.
can do some analysis, but not quite enough. And those are all different disciplines. And so we have that same thing within our software. Obviously, within a SaaS or a pure software company, they're going to have all those different disciplines. But we also have that in a spacecraft company as well. So that answers your first question. Second one is kind of how we use AI. So, we work in the defense space. We're a dual use application. So obviously the security around the data that we create is paramount to work with the Department of War. That is kind of first priority. Very, very close second priority is that we are competitive in the market as in terms of how AI forward we are. So as soon as we get the right kind of cybersecurity and controls in place, I tell my team that there is not a limit for how many tokens you can use, because it's all that cost compared to hiring more people is like 10 to 1. And so, one of the things that I think hardware companies have, or companies that also build hardware have had to kind of deal with is something around like the shame or the guilt of using AI, where people kind of don't want anyone to know that they used AI to write a really big document, or and it got them 80% there. Obviously, you're absolutely responsible for anything that you put out as an engineer or an analyst or whatever. But the way I look at it today is, if you spent that whole time writing it out by typing every single word, just like a software engineer typing out every line, like, I'm pissed because you were inefficient. I don't care if you can kind of tell that it's AI. It needs to be accurate, it needs to be complete, it needs to be rigorous, but we absolutely need to use the tools at our disposal to move as quickly and as efficiently as we can. On the hardware side, it's very similar to somebody that like still wants to use a drafting table instead of using CAD. That would be pretty silly. But again, paramount to all of that is the cybersecurity and the data handling and things like that. So, we have to be compliant there first, and then we kind of dive head first. We can do that, right? So we are compliant on the cybersecurity, and we heavily use AI to assist our teams, both on the hardware and the software side. So it can be done. It is not a you do defense, therefore you can't use AI kind of situation.
Over the last year and a half, have you seen step shifts in some of the abilities that AI has even allowed you and your team to do? And I feel like even over the last 3 to 6 months, it continues to accelerate. What are some of those big like unlocks maybe that you've been able to see with AI helping your team? And then how do you project that forward? Where do you imagine this unlocking for either your team, but also a lot of people that are in hardware over the next, 2 to 3 years even?
Yeah, so I'd say, like, I'm never quite clear on the chronological order. So the last 3 to 12 months, somewhere in there, we saw this massive shift in efficiency of software engineering that exists, outside of the actual big AI companies and stuff, and kind of like propagated through the rest. So we saw that for sure. We had one instance where we were planning to hire two contractors as search support on software for the vehicle. The head of software like forgot about it. And I came back to him a couple weeks later and I said, "What happened to those two contractors that you needed for search support?" He's like, I don't need them. Like, we were able to cover what we needed, using kind of the efficiency gains that we got out of software. So, so that's massive. We see it very much as an efficiency multiplier, as opposed to kind of taking the roles of our senior engineers or anything like that. So we haven't reduced our actual team size as a result of that in any way. So that was a massive example that I had kind of personally, and I don't think that's quite happened on the hardware side. Like, our engineers still do drawings and do CAD kind of click by click, and I think sometime in the next 6 months, that's going to change. There's a lot of people looking at hardware design and CAD design using AI, and it's like not quite there to the tools that I've used, but something's going to flip and it's going to be there. And all of a sudden, nobody is going to build CAD, click by click. And it's going to totally change the efficiency on that front. One of the other places that we use it a lot is on drawing checks, and it's not writing anything there, it can't necessarily change it, but it's you stare at enough drawings and your eyes like glaze over, and you miss these little tiny mistakes and stuff like that. And AI is great at never having its eyes glaze over. So that's one of the biggest parts on the hardware side that we use it. We also use it on a lot of data analysis and kind of post-test analysis and things like that.
Yeah. I think it's going to be an exciting future in the short term as it continues to be, I agree, more helpful on the hardware side where we haven't had quite as many unlocks. I think it's going to open up a whole new way for founders across all these hardware problems to exist, which is going to be great. And then also for far less funding and fewer people to build very meaningful things. So it's a great time to be building. It feels like it's a great time to be building in space. On the VC side, I would say, other than AI, but I feel like AI is kind of its own little category that just obviously has so much large players that control the narrative. I would say space, in my mind, is equally as hot right now from a industry to invest in, that people want to work in space. I find that some of the most talented hardware engineers like yourself like the challenge of building in space because of how complicated it is, and that obviously attracts some of the best talent. How have you felt the momentum? Because I feel like it's shifted. It's been there for the last maybe a couple of years, even when you started, but really has shifted and accelerated over the last 6 months or so. Have you felt that? What does it feel like to be building in space? Has that been a blessing or a curse on the fundraising side, on the hiring side? Maybe talk a little bit about just the high level space industry and how that momentum feels.
Yeah, I mean, I think that, our fundraising journey is actually a really good example of that. The lead from our pre-seed round, which we did in Q1 of 2025, Space Capital, they are space specific. They
I
have a
love space capital.
portfolio
Yeah.
full of space stuff, from the application layer to the infrastructure to what is enabled, like, things like Uber and stuff like that, but they are very space specific, right? So they led our pre-seed round. Fast forward to doing our seed round, it's led by a firm called Convoy with a K.
Local Colorado.
Yeah, also from Colorado. So we love that. They are not traditionally from space or defense tech or hardware. And they see the change in kind of in the space, and it becomes more secure to people that aren't super knowledgeable about space, and they can kind of venture into that, no pun intended. And they bring this like very fresh view that's kind of gets us out of our echo chamber in the space industry, that is extremely helpful. I think there's lots of biases that we have being space nerds, that we need people from the outside to look into that. So, we've been able to kind of create a really great syndicate of investors that are a mixture of that really help to provide differing views on things that aren't just kind of in that echo chamber of space. And so I think we're going to continue to see that people that are traditionally not investors in space coming into space. The SpaceX IPO, Hawkeye 360, York, things like that, those all kind of give security to non-space investors that space is more of a, more safe bet, right? Venture is never safe in general, but it does show that the space companies have exits that aren't acquisitions all the time. And I think that will bring a lot more liquidity and a lot more capital. We've definitely seen that in the news with other companies' rounds that are, very large. And that is from other non-space companies, investors, coming into the space. So we've definitely seen that.
The SpaceX IPO, I think, will be one of the most like transformative points in tech history, if only because, to your point, it's going to show obviously the most valuable company in the world would be a space company, but then also, or one of the most valuable companies, the fact that there's going to be so much wealth generation to other space nerds that are going to want to continue to play in space, I think is also why it's going to be so important, because I can't think of another IPO with a set of individuals that are so passionate about continuing to build in space. It's why you see so many founders like yourself that go from SpaceX to founding companies. If now all of a sudden you have hundreds or thousands of them with meaningful capital to reinvest back in, I think it's just going to create a whole nother wave. We're already seeing it. You mentioned on the investor side, more investors that a year ago were not investing into space and now are. That creates an influx of capital. But I think that the SpaceX IPO alone is going to bring more investors that are now more optimistic about the return on investment, but also now new people entering the arena that are very wealthy and want to continue on this path. I think it feels like, I would say, there's no better time to be building in space. The other kind of question on that is, have you felt the talent pull? I think that there's a lot more talent that I think maybe also wants to work in space, but because there's also more companies that are building in space, is it harder to recruit talent to any particular company? How has that felt from a recruiting side?
So we have pretty specific criteria right now with where the stage of the company is at. We have a requirement that anybody technical on the engineering side that joins the company has to have hardware in space. Great if it's working, actually a little bit better if it's been through a failure. You learn a lot more through a failure and getting through it than you do, a successful, launch. One of the funny things is like you have a success in space and you instantly look forward and you don't look back. And when you have a failure and you do a failure analysis, you actually see the 16 other things that almost caused the failure but didn't.
Yeah.
And then you find the other one and you actually learn so much more about your system. So that being said, there's a relatively small pool of people that we really go after for recruiting talent. Once we have critical mass of those, then we can take on, much more junior engineers, people not necessarily from the industry, and things like that. But at our current size, that's really, critical. So that being said, these are people that have been in the space industry, in the satellite industry, in the hypersonic industry for, 8, 10, 15, 20 years already. And so that doesn't necessarily kind of change as a result of the IPO. Mean, I think what I think that we're gonna see on the SpaceX, kind of liquidity event, is there's gonna be plenty of people that retire out of the workforce, and take early retirement, and they're totally fine. Maybe they'll invest in companies like us, and that's great.
Or maybe they join small startups because they don't care about the money anymore. Yeah.
Yeah, exactly. And they care about that mission. So I think there's a lot of things. What that'll actually do at a macro perspective, and will it constrict talent? Will it not constrict talent? It's kind of unclear. For us, we're finding people that are very driven by the mission that we are building, and you end up that plus the experience level and the discipline that we need. It's a pretty small world that we go from. Most people know each other. A lot of it's based on referrals and things like that. So we haven't necessarily seen a change in that, and we haven't necessarily seen any difficulties with that. I would say when you get to new grads and kind of hiring for that, I think next year, the year after, beyond that, you're going to see a lot more people graduating with space specific kind of hardware,
That's so true.
software degrees, which I think is great. We will be in the perfect spot to receive all those people and bring them into the fold with a great kind of senior engineering team to go with them.
Yeah. How have you felt that building this in Colorado has
Yeah.
benefited or held back or any of those things? I feel like Colorado, some people are surprised, others are not. I think Colorado is one of the best places to build for space. And obviously, we just had the Space Symposium here a few weeks ago. Space is still very much alive here in Colorado. Talk maybe a little bit about what it's like building in Colorado, specifically on the hiring side, but even just on the logistics side.
Yeah. Um, the you have to have an ecosystem of somewhat similar companies to be able to pull from, as well as to be able to pull other people from other locations. So if we recruit somebody from LA or Austin or Seattle, and there are no other space companies that they could work at, if by chance it doesn't work out with us, that's like a pretty big risk for them that they're guaranteed to have to move again. But if they come work for us, and if by chance it doesn't work out, or 10 years from now, they want to work at another company, there are others to do that with. And that's really important to have that ecosystem. And, similarly, we have people that don't all have to relocate. So that ecosystem exists. It's very strong, and it's supported by the primes like Lockheed and ULA and Sierra Space and BAE, as well as a large array of startups, right? When I looked at moving back here to Colorado about 10 years ago, there was the primes, and that was kind of it. All these companies, one of them that I worked at, Loft Orbital, sprouted up in the last like 5 years or so. So that's really great and makes this a really great place to build in. So I'm happy that I happen to love satellites, happen to grow up in Denver, and happen to love Colorado. Those all are just luck, I guess.
Yeah. Yeah. It's a great place to be, a great place to build. What other problems, companies, you can name specific startups, excite you besides what you're building in space right now? Like we mentioned, it feels like there's so many companies that are starting right now, solving all these different problems. Are there any that are outside of what you're building that you look at as going like, that's awesome. I'm glad they're building that.
Yeah. Even when we go to mass as being less of a limiter, the area that we need for solar ends up being a separate limiter on, like maneuverability. And so I'm really excited about kind of power grids in space and different methods to get power, whether that's microwave or direct or whatever. There's a couple companies going after that we're close with, and we're really excited about that. Meaning that we can have a smaller solar array or smaller receivers and get massive amounts of power. As we support the in-space manufacturing ecosystem as an infrastructure provider, getting very large amounts of power is critical to some of the applications that are very early in their phases, and kind of power being a limiter is a big one. So obviously, that one's really exciting. And the other one, is really launch. Like launch, we know will not be the limiter, but it can't get here fast enough from the other companies that we're really excited about, like Blue Origin and Stoke and Relativity and Firefly and Rocket Lab. Like we're really excited about the competition in that space and getting new capabilities and a higher cadence kind of getting going there, and obviously Starship as well. Still very excited about launch too.
Thank goodness that those people that started those companies didn't turn away when all of their investors probably said, isn't SpaceX going to just beat you
Yeah,
and do this?
exactly.
It's a
Yeah.
lesson for
Have to
founders
have
out
competition.
there. Oh my gosh. You have to have competition, but I always feel like from the investor side, and I'm very guilty of this, all investors are, you always look at the winner, and SpaceX is such a clear winner because they've had such a big head start. They've been doing it for a long time. They've perfected it in a lot of ways that they still have a lot of room that they'll continue to improve. But I hear from everybody the same point that you just made, that they cannot wait for all these other players to come onto the scene, and to continue to meet and match the level of where SpaceX is today. Because I think what people misunderstand about space is that there's an economy just waiting to be had there that is just like barely getting started. Obviously, there's a lot of wealth, and SpaceX becomes $1 trillion company, and there's billions of other dollars going into these companies today. It's still a fraction of what the ecosystem in space can be and will be over the next decade. And it's because, like, to your point, I mean, launch being a limiting factor, energy in space, all these things, it's an infrastructure that needs to be built out in space.
Yep, absolutely. I'm super excited to be building in the space industry and kind of enabling the next level of scale. It was really exciting to see Starlink kind of with these applications for the FCC of like 30,000 satellites, which was
Yeah,
insane. And then we've
insane.
got more recent ones that are on the level of 100,000 or 1 million satellites. And you compare those numbers to automotive or consumer electronics, like they seem large on satellites. They are still dwarfed by the automotive industry, the consumer electronics, laptops, smartphones, things like that. So we have a lot of, we have a long way to go to kind of really hit the orders of magnitude of value that we can get out of the space industry. And, space is big. We have to deal with orbital debris. Obviously, that is a thing that we kind of clean up on our own for our own satellites by bringing them back. But space is really big, and there's a lot of applications that aren't really taking advantage of it fully because previously launch was the limiter. Now it's how fast can you get a satellite onto a rocket limiter, which we're trying to address, things like power and communications and things like that. So really excited to see all of these things, progress.
I made the other stupid mistake of asking Philip Johnston from StarCloud last year of like, are we running out of space in space? And he got very nerdy and like explained very clearly of like how much space there is in
Yeah.
space. So when I was hearing like 3,000, like, are we going to get crowded? And space debris is a problem. Obviously, you just don't want objects floating around and hitting things and stuff like that. But there's so much space in space. There's so much room to continue to grow there.
Yeah. You think about the ocean and then
Yeah.
you extend that out on a sphere and it just
Yeah.
gets bigger, right?
Yeah. Exactly.
And
And obviously the different orbits and stuff too.
yeah, absolutely. So
Yeah.
there's a lot there.
We like to end these conversations with a lot of the founders that are listening. Like I mentioned, a lot of them are interested in starting in space, starting hardware companies. What's some high level advice or inspiration that you could give some of the founders listening right now? Whether it's, mistakes that you made that folks getting started right now can learn from, advice you'd give them on the hiring process, or anything that maybe stands out that you would give to hardware or space companies and founders that are looking to be where you are in a year or two.
Yeah, absolutely. Well, I would say one of the biggest ones is run a process on everything that you do. And it ends up being a very similar process. And this is actually not a thing that engineers do as their normal kind of workflow. But like the sales pipeline was this kind of thing that I had never had to deal with as an engineer. You do initial analysis, then you do detailed analysis, then you get it built, then you test it, and then you fly it. But the kind of sales process in general, both for government, for commercial, as well as for fundraising, as well as for hiring, right? Like it applies across all these other facets of the company that are not technical. but it is actually the same process of a pipeline and a funnel. And there's a lot of different theories you can follow on that. But if you run that with investors and fundraising, you run that with hiring, you run that with commercial customers, you run that with government customers, you run that with, kind of anything that you need to do that's external facing, where you need to get the best kind of thing and hit certain targets, run that same process on all of those. That being said, the end of that process is what makes a press release, not the middle of that process. And so despite whatever you see in press releases of how easy a sale or a raise was, that's not how it actually went. And so, just kind of keep trudging through that and trust the process that you've set up for it.
Yeah, one of the more common mistakes that we see founders at every level is you do have to move fast and break things, which I feel like is one of the most like misleading quotes ever created. Because I think so many founders just like they go into it and they become almost too rebellious. But if you can move fast and simultaneously build out these processes that you're learning and iterating from and moving quickly, maybe you're not the slowest or fastest out of the gate, but you will certainly be the fastest over. It's a very long journey. You mentioned you're a year and a half into this. You got another decade plus to go before some of these things happen. Building those processes, you're right, is one of the more valuable things you can do. And the earlier you start, the better for sure.
Yeah, absolutely. And the processes I'm talking about are one person processes. This isn't across the company with a QMS or, whatever. It's the Excel sheet that you use to track what you're doing versus being like, I can track that all in my head. Like you can't.
Yeah.
So, yeah.
Brian, I really appreciate this. This was a great episode. Like I said, space, I think, is so fascinating to me and other people. Thank you for educating us on a lot of things, telling us more about what you are doing. Where can folks continue to follow along with you and the company and continue to follow the journey?
Yeah, absolutely. So our website is luxaeterna.com. We've got roles open right now. We'd love to see folks apply that have hardware in space, and especially ones that have failed and have been through that failure. That's great. We're also active on LinkedIn, and you can find us there.
Love it.
Great.
Brian, thank you. I hope that I can see you in person here soon. You've extended the invite. I just need to find the time to get down there and see your beautiful space.
Come on by. You can see part of it behind us. We actually got a clean room installed on Friday.
That's
got
awesome.
done at like 11:30 p.m. And so we're really excited about that and going to start building flight hardware here very soon.
Love it. All right, Brian, thank you so much. And we'll talk again soon.
Great. Thanks a lot.
Hoist the black flag high, let the cables hum. Code and cannon ready, futures beating like a drum. Charts are drawn in circuits, treasure maps and AI.